So this is kind of the pattern of geometry in the beginning of a unit. There's some definitions here. So parallel lines is the geometric idea. Is coplanar lines. What does coplanar mean?
On the same plane.
Same plane, yeah, that don't intersect. So coplanar lines are lines in the same plane. If you want to write that, you can. Lines in the same plane that never cross. Intersect means cross. So lines in the same plane that never cross. You guys see it when it's like this? Is that too small on the back? Okay. So coplanar lines that don't intersect. Skew lines. Here it is for skew lines. This is a new word. Non-coplanar lines that don't intersect. So that means lines that are not in the same plane and they don't intersect. Like we have some skew lines here. How about this? Like if you look in the carpet here, you can kind of see there's kind of some lines that show up. But if you were to picture some line or a seam, there's one right here, I think, right in front of it here. So a seam, so there's a line in the carpet going this way. It's in a different plane. Then you see these little bands up here, right here. These guys up here, you see this one. There are these, and so right here, just the framing that holds up the little here. But this one right here that goes that way, and this one right here, the seam along here that's going this way, those are skew lines. Now, if I were to take like this line and maybe one directly above it, there's actually a plane that you don't see it because there's not a wall right through here, but there is an imaginary plane that comes straight down through here and would include maybe one of the lines on the carpet. So it's probably best if you're going to draw skew lines or represent them, is that you have ones that are like, if you were to press them together, they'd be perpendicular. So we have these right here going that way are skew with these lines going this way, or a line that represents a C going this way. So those are skew lines. Parallel planes we talked about, planes that don't intersect. And then the transversal, I'm going to have pictures of transversals on here, but a line that intersects two or more coplanar lines in transversal. All right, so we are looking for, here it says identify which line or lines fits the description. So we'll get some examples of these definitions. So parallel to AB and contains D. So a line that's parallel to AB that has D in it. Let's see, it's going to be parallel to AB. It'd have to be DC because to be parallel, it has to be coplanar. That means that's going to be the same plane. And then it also, they can't ever intersect. So yeah, just erase it. The move. So C, line CD, and that does have arrows on the end there. Can't see it. we're taking this box right here to represent a space, but you can picture that the lines are not actually segments, they go forever, and that the box could go in all directions, so it's a space. Perpendicular to AB, so perpendicular to AB and contains B. AB, yeah, so it'd be line AB, that's the line marking over the top of that. By the way, guys, I don't know if you guys come in this morning. I've got topics 1, 2, 3. Tomorrow at lunch is the last chance. Last chance. Tomorrow at lunch. Last chance. Yeah. Kind of grading them during 4th period prep today. See how fast it goes. I don't know. These are new tests for me, so but there's a lot of reading I have to do. If you guys did really well on them, it'll go really fast. If I'm trying to assign partial credit here and there and can't, you know what I mean? It takes longer. So it depends. I don't know. You guys, depends on how you did. So right here we've got skew to AB and contains D. So we're going to look for some non-coplanar lines. So some lines that are not in the same plane as AB. So they couldn't be in this top part of the box. They can't be in the top part of the box, nor on this left side of the box, nor in some imaginary plane that comes diagonally through here either. But in terms of the planes that we have drawn up here, it can't be in this vertical left side of the box nor the top part of the box. So some ones that would work here would be ED. Line ED is skew to AB because it is not in the same plane as AB. It's neither in the top nor that left side there, and it's never going to intersect with AB. AB is just cruising along like this, and that one's coming through like this. So they are skewed. They're never going to intersect. And then DH is another example. So this is what I was talking about. This one's going this way here across the top, and DH is up and down. So it'd be like my example with the carpet seam and then that perpendicular framing piece on the ceiling. Those are skewed to each other. They're never going to intersect. They're also not in the same plane. So skew is different from parallel in that sense. Because parallel means they're never going to intersect when they're parallel, but they're in the same plane. And then DG is another one here. So DG is another one. So it's not in the same plane as AB. It's not in this top part here, nor in the left side. And they are never going to intersect. So this little diagonal coming through DG is going to just keep on going. It's never going to intersect with AB. So those are some examples of lines that are skewed to AB and contain D. And then the last one on here is a plane with D in it and parallel to ABE. So yeah, DCH would work, or DGH, any 3 letters that you want to use to name this plane right over here on this side that's parallel to this plane over here. So 3 letters name the plane. So it's like the side walls here that we have in the classroom. All right, famous parallel postulate. This is actually a pretty important postulate among the postulates for the geometry that we study in high school. It says if there is a line and a point not on the line, so if there is a line and a point not on the line, see right here, line, then there is exactly one line through the point parallel to the given line. So there is only one and only one line through that point parallel to the given line. And then if there's a line and a point not on the line, then there's exactly one point perpendicular to the given line. It's the same thing, a line, point not on the line. There is one and only one line perpendicular to that given line through the point. So maybe draw a picture of each of those postulates. Pretty intuitive, I think. All right, and then there are 4 types of angles that we need to be familiar with, and it's based on their position. And the name that we give them is supposed to help you to recognize the angles. Okay, so here we have an example of 2 lines that are not parallel. They're in the same plane. They're not parallel. It's cut by a transversal. We call this right here the transversal. Trans versus this line right here and this line right here. It goes right through both of them. So we call that the transversal. All right. So here's what it means to be corresponding angles. And then eventually we're going to talk about, well, what happens when I take each of these lines that I'm going to highlight here. If I take this line and this line that I highlight, and all of a sudden I make them parallel, there's special properties about congruence or stuff being supplementary that comes into play with these special types of lines. Okay? So all right, so for corresponding angles, here's what it means to be corresponding. If you're to take this set of angles and slide them down so that they overlay this set of angles, corresponding means they're in the same position relative to those top angles. Does that make sense? So corresponding means they're in the same relative position. So like right here, angle 1 right here is in the same relative position as angle 5 down here. Okay, it's in the top left of this grouping of 4 angles. Okay, and angle 2 is in the same corresponding position as angle 6, right? And then angle 3 is in the same corresponding position as angle 7. And then angle 4 is in the same corresponding position as angle 8. So corresponding angles are in the same relative position. So let's just write that down as a definition. So same relative position about different vertices. So we want to give some examples of some corresponding angles. So we did it already here. So corresponding angle examples would be angle 1 and angle 5 are corresponding. Or angle 7 and angle 3 correspond. Or angle 4 and angle 8 correspond. And then finally, angle 2 and angle 6 correspond. So we've got 4 pairs of corresponding angles. So same relative position about different vertices. So that's what the word corresponding means. Like in geometry, we talk about corresponding parts of 2 different triangles. We're talking about if you were to take one triangle and overlay it with the other one, it's the parts that match up. Okay. I'm just going to erase just this little bit. I'll keep the rest. I'm going to talk about a different set of angles here, different types of angles. So those are corresponding alternate exterior angles. Alternate exterior angles. So what's that? 8 and 1, yeah, that is it. So that word alternating, it shows up both here and here, and it means the same thing. It means opposite sides of what we call the transversal. Okay, so here's the transversal coming through here. Alternate exterior or interior means they're on opposite sides of that transversal, the red line. Okay, that's the alternate parts. So alternate exterior angles. They have an AKA that might help you remember. If it works for you, I'll tell you what it is in a little bit. But alternate exterior angles, an example would be angles 1 and 8. Yes. So exterior, what do you think exterior means? Outside, yeah. And what we're talking about is outside of these guys. So outside would be this direction or that direction. Okay. That's what we mean by outside. They have an AKA, we call them the haters. You guys use that term anymore, haters? No. Come and go. Some of you do. Okay. Anyways, their AKA is the haters. Why do you think we might call them the haters? Because they what? They're outside, yeah. I mean, in terms of being far away from each other, they're about as far as you can get, right? Does that make sense? So we call them the AKA the haters, but that's the alternate exterior angle. So the exterior part here is what I've drawn with the little arrows there. And so I think the definition is kind of in the phrase, the alternate exterior angles. Could we give some, AKA the haters, could we give some other examples besides angle 1 and 8? So angle 1 and 8 are alternate exterior. 2 and 7, yeah. 2 and 7. So maybe just the word, I don't know if you want me to define alternate, define exterior. If we want to, we could say opposite sides of the transversal, and then top or bottom of the lines cutting the transversal. All right, what about alternate interior angles? Let's see if we can get those. Yeah, so alternate, we already talked about alternate. Interior just means inside, and here, it's the inside zone. Picture it. So alternate interior angles are 3 and 6. And angles 4 and 5. The only goal today is that you can just recognize these 4 different angle types. That's it. Maybe add skew, what skew lines are to your vocabulary. I think you probably knew the other 3 things on there. But add skew lines to the vocabulary and these 4 different angle types. If you can recognize these 4 angle types, you can say the alternate interior angles, aka. Oh yeah, now I remember. I was trying to think, what is the AKA? Well, we've called them before. I've seen them called, and I didn't come up with this. The Zorro angles. How Zorro would, if I spelled that right, is it 2 R's in Zorro? No. This is how Zorro would, yeah, do a little Z with his sword. Yeah. And so there's Zorroing, like here's the Z for Zorro, and so they're kind of encompassed inside the crooks of the Z, or it could be a backwards Z, I guess. So they're inside the crooks of the backwards Z. The Zorro, yes. What's that? The Zorro. I have to Google Zorro. He's a hero. I mean, movies about it. He was he somebody who stood up? He's kind of like a Robin Hood for maybe the Mexican people, maybe a legend for Mexican people who would come and save them from the rich oppressors. I think. Am I right? They're kind of like a Robin Hood sort of character. What's that?
I was way off what I thought it was.
Oh, what you thought it was? Okay. I think it was in the 90s. They had a couple movies come out with them. So if you go on YouTube, if you look on YouTube, The Legend of Zorro, Mask of Zorro, a couple movies there. They're kind of fun movies.
Just Google me and make it easy. Just do that.
What's that?
Just Google and make it easy, please.
Making a Z. We can do that afterwards to help you remember. So that'll help you remember. Alternate interior angles. And then the last one on here are the consecutive interior angles. And they have an AKA.
That would be like 55.
For us, it's the same side interior.
Oh, does it say same side on yours? Oh, maybe I changed it. Okay, hopefully I changed it. That's the thing. I pulled up my same side interior angles. Depends on which textbook you're in here.
So it
So-
would be like 3 and 5.
Same side interior angles. So we're gonna call it. They are. It's 3 and 5. Yeah. What's up?
What would be the definition for the interior?
The interior. Interior means inside or in between. So interior is inside or in between the two lines. What's that?
Transfer.
Well, yeah. So we're gonna. This is the single line cutting through both of these. We call it transversal, but yeah, it's in between those two lines that are not parallel. But when we use this, we're going to use it mostly with them being parallel, and then there's special properties about these four angle types. They're either congruent or supplementary. To be a spoiler. Okay, so, yeah. But if you can at least recognize them, so same side interior angles, same side interior angles. So same side of the transversal, and then interior we already talked about. Here's the transversal here, here. So same side of the transversal, so it'd be like 4 and 6. So angle 4 and angle 6, and then what else? Angle 3 and 5, you told me? So if the alternate exterior angles are the haters, what do you think the ones that are, it's like, they're as close as they can be. So they're in different neighborhoods that they could, I don't know, like Morse code flashlights. So that was before. They could wave at each other, there's nothing between them. Okay, so they are actually the lovers.
Yes.
So AKA the lovers.
That was close enough.
The couples, okay, yeah. So lovers. I'm not creative enough to come up with that. Somebody did. Okay. That'll help you remember them. But you need to know those four angle types, okay? You know those four angle types. Any questions on this?